Hello, this is Dr. Grande. Welcome to my video on conducting a discriminant analysis in SPSS using a dependent variable that has 3 levels. A discriminant analysis calculates the probability of group membership based on a series of independent or predictor variables. The predictor variables would be measured at the scale level of measurement, and the dependent variable would be categorical. It's not unusual using discriminant analysis to have a categorical variable with 2 levels, and I have another video that covers that, but in this video I'll be going over a dependent variable with 3 levels. The assumptions for discriminant analysis are somewhat strict, and if you have data that does not meet the assumptions for discriminant analysis, and you have a dependent variable with 3 or more levels, you can use a multinomial logistic regression, and if you have a dependent variable with 2 levels, you can use a binary logistic regression, and I have videos on those topics as well. So taking a look at these fictitious data, I have loaded in the data view in SPSS. I have an outcome variable. It has 3 levels, 0, 1, and 2, and those correspond with no relapse for 12 months, relapse between 6 and 12 months, and relapse within 6 months. So let's assume these data come from a substance use treatment facility, and we are categorically measuring the outcome, and all outcomes will fit in one of these 3 categories. So somebody finishes the program and there's no relapse for that participant for 12 months. That's one category. And then you have 2 categories where there could be a relapse between 6 and 12 months and under 6 months. So these are mutually exclusive categories. A participant has to fall into one of these 3 categories, and that is required for discriminant analysis. The dependent variable categories must be mutually exclusive. Then for our predictor variables, we have a measure of anxiety, a measure of depression, and a measurement designed to capture psychosocial stressors. And these are all measured using t-scores. Now, t-score is a standardized score with a mean of 50 and a standard deviation of 10. And the direction of measurement is identical for all 3. So a higher score, for example, on the anxiety inventory, represents a higher frequency of anxiety symptoms, and a lower score represents a lower frequency. An assumption of discriminant analysis is that all the predictors are independent. So we will assume these predictors are independent of one another. The predictor variables should also be normally distributed, and there should be an absence of outliers. In terms of the sample size, you'd like to have 5 times as many observations as predictor variables. In this case, we have 3 predictor variables, and we have 48 observations. So we've met that assumption. So at this point, I'm going to test the predictor variables to make sure they're normally distributed and to make sure there are no outliers. And we can check both of those assumptions using Analyze, Descriptive Statistics, and Explore. I'm going to move all 3 predictor variables over to the Dependent List box. Then under Plots, I'm going to uncheck Stem and Leaf and check off Histogram, and then check off Normality Plots with Tests, and click Continue, and then click OK. And this will give me the descriptive statistics for the 3 predictor variables. So what I'm interested in here, specifically for the assumptions of a discriminant analysis, would be the p-values for the Shapiro-Wilk. And I'm looking for these values to be non-statistically significant if I'm going to meet the assumption of normality. And we can see 0.912, 0.193, and 0.073. So evaluate at the 0.05 alpha. All 3 of these variables have a non-statistically significant finding, so we'd assume that they are normally distributed. As far as outliers, we'll take a look at the 3 box plots. The first one, anxiety. We have no points plotted below the bottom whisker or above the top whisker, so we'll assume we do not have any outliers for anxiety. Moving down to depression, same thing, no outliers. And then the last variable, psychosocial stressors, again, no outliers here. Another assumption is the relationships between all pairs of predictors in each group are linear. So to test this assumption, we're going to need to split the file. Just go to Data and Split File. We want to organize the output by groups, because the assumption is the relationships between all pairs of predictors in each group are linear. So I need the output organized by groups, and of course the group here would be outcome. So groups based on, I put outcome in that list box and click OK. Now the file is split. I go to Graphs, Legacy Dialogues, Scatter Dot. I'm going to use a matrix scatter. And I'm going to move all 3 variables over into the matrix variables list box and click OK. And because I have the split file on, I'm going to get these 3 graphs. So what we're really looking for here between all these pairs is a pattern where the points start off in the bottom left and move to the top right in sort of an elliptical pattern. And more or less that's what we see for the no relapse for 12 months. I mean, they could be more tightly grouped, but this appears acceptable. And then for between 6 and 12 months, a few of these look better than others. This one looks pretty good. This one not as much. And then for the relapse within 6 months, the depression, anxiety grouping, pretty good. Anxiety and psychosocial stressors, pretty good. But the depression and psychosocial stressors is not quite what we want. So we make this judgment about the linearity just by looking at these, and in general, most of them appear okay. So we're going to move forward with the analysis. It's important at this point to remember to take the split file off. So we now want to analyze all cases and do not create groups. This top radio button and click OK. The last assumption that we'll test outside of the discriminant analysis procedure is the assumption of no multicollinearity. And we'll do that by hitting Analyze, Correlate, Bivariate, and loading our 3 predictors into the variables list box here to the right. And we'll keep the default settings, a 2-tailed Pearson correlation coefficient. Click OK. And you can see we range here from 0.302, that's the weakest correlation, to the strongest, which is 0.558. There are a few different definitions for multicollinearity, but in general, if you're below 0.8 or 0.9, this assumption would be considered satisfied. So here we do not have multicollinearity. So now we can open the discriminant analysis dialog and configure that to run the discriminant analysis. That will be Analyze, Classify, and Discriminant. And this is what the dialog looks like by default. The grouping variable will be the outcome, and it's going to ask us to define the range, so I'll do that now. The minimum value here would be the no relapse for 12 months, which is 0, and the maximum was the relapse within 6 months. That was 2. I'll click Continue. So this range is now defined, and the independent variables will be psychosocial stressors, depression, and anxiety. We'll move those over into the independence list box. I'm going to keep this checked off, entered independence together. This is the default setting. I'll keep that radio button checked. Up in the statistics button, under that button, we'll go with the within groups correlation, means, univariate ANOVAs, boxes M, Under function coefficients, Fisher's and unstandardized, and click continue. Under classify, in this case we do have all the groups being equal. We have 16 cases for each level of the outcome variable. And I'm going to stay with the within groups covariance matrix. I'm going to add summary table and leave one out classification. I do not have any missing values in this data set, so I'm not going to replace missing values with a mean. There's no need to. And then under save, I want the predicted group membership, the discriminant scores, and the probabilities of group membership. And click continue. And now the discriminant analysis is ready to run, so I'll click OK. So in the first table we can see again here no missing cases. Under group statistics, we have the, among other information listed here, we have the means for the 3 levels of the outcome variable, and then for each of the predictor variables. So you can see the means tend to be the lowest here for the no relapse for 12 months, and tend to be more in the middle here for the relapse between 6 and 12 months, and then the relapse within 6 months. These are where we see the highest means for anxiety, depression, and psychosocial stressors. And again, this is what we might expect to see if these were real data we were using. Moving down to the tests of equality of group means, we have statistical significance here for anxiety, for depression, and for psychosocial stressors. I'm going to move down to Box's test of equality of covariance matrices. And we can see the log determinant column here. We want all 3 of these values to be pretty close together. And as you can see in this case, they are. And then we also want to evaluate Box's M, the p-value 0.362. That is not statistically significant. So we will assume we have equal population covariance matrices. Now it's important to note here that with Box's M, we are evaluating the p-value with an alpha of 0.001 and not the 0.05, which is common for many tests. We can see under this next table, eigenvalues, that there are 2 functions listed here, function 1 and function 2. And what we're looking for is the function with the greater eigenvalue. And here there's a fairly large difference. So the higher the eigenvalue, the better the fit is. The better the data fit this model. And when we look at the canonical correlation, we can see it's 0.873. And we want to square this to get the effect size. And here we see with Wilk's lambda that the prediction model is statistically significant. So we're going to be using function 1 for this analysis. Then we have these standardized canonical discriminant function coefficients and the structure matrix. And ideally these would be relatively similar. In this case you can see anxiety 0.498, here 0.614. So a little bit apart there. Depression at the structure matrix 0.505, and up here 0.681. So again, not as close as we'd like. And then the psychosocial stressors 0.665, and down here 0.527. So they're not as consistent with one another as we would like. But one thing we want to check in the structure matrix is all of these correlations are greater than 0.3, and we do have that. All 3 variables display a correlation in the structure matrix greater than 0.3. Then we move down to the canonical discriminant function coefficients. So this is used if you want to build the discriminant function. You have your constant here at the bottom, and then all of the unstandardized coefficients for your predictor variables. In this case, again, we're just using function 1, and these 3 unstandardized coefficients are listed. Next we have the functions at group centroids. Again, we're just looking at function 1. As you can see, these are the unstandardized canonical discriminant functions evaluated at group means. And you can see we have pretty good separation here. For the no relapse for 12 months, this is negative 2.2. The relapse between 6 and 12 months, 0.3. And relapse within 6 months, 1.9. Moving down to the classification statistics. If we look here at the Fisher's linear discriminant functions, notice that the highest values are associated with the relapse within 6 months, the lowest with the no relapse for 12 months. And then moving down to the classification results, what we're looking for here is the percent that the model accurately predicted the outcome. Right, so we look at no relapse for 12 months, and down here, no relapse for 12 months, 93%. Relapse between 6 and 12, and the corresponding level here, 75%. So the model didn't classify this group membership as accurately. And then relapse within 6 months, compared to the same level, 87.5%. So the highest percent of correct classifications is in the no relapse for 12 months, and the lowest in the relapse between 6 and 12 months. We also want to look at the bottom here. We can see that 85.4% of original grouped cases are correctly classified, and 81.3% of cross-validated group cases are correctly classified. If we move back now to the data editor, we have variables that I saved as part of the discriminant analysis procedure. And you can see the first one, the DIS_1, is the predicted group for analysis 1. Then we have the discriminant score, and this is for function 1. And this is the discriminant score function 2, so I'm going to clear this one because we're not using function 2. And then we have the probability for each case of group membership in level 0, which is the no relapse for 12 months, and level 1, which is the relapse between 6 and 12 months, and then level 2, which is the relapse within 6 months. So you can see for this first case, the true outcome was no relapse for 12 months. The predicted outcome was the same. We have the discriminant score, and you can see there was a 77% chance that the group category was no relapse for 12 months based on these 3 scores, based on the anxiety, depression, and psychosocial stressor scores. And as we can see, for this first category, the no relapse for 12 months, if I carry this over, there was only one case that the model classified incorrectly. Looking at case 16, the probability it determined was 81% that the group membership was level 1, even though it was actually at level 0. Moving down to the relapse between 6 and 12 months, and drawing the same comparison, there were 4 misclassifications, and all the remaining, of course, correct. 2 misclassifications, no relapse for 12 months, and 2 relapse within 6 months. And then looking at the last category, you see the relapse within 6 months was correctly predicted except in 2 cases, and those predictions were relapse between 6 and 12 months. So this provides a lot of useful information. You have the predicted group membership, the discriminant score, and all the probabilities. And it's interesting to see how some of these probabilities break down. For example, for case 19, there was a 43% chance of group membership in the no relapse for 12 months and a 54% chance for relapse between 6 and 12 months. But if we move to case 14, we can see there's a 99% chance of being in the no relapse for 12 months and a less than 0.5% chance of being in the relapse between 6 and 12 months. I hope you found this video on conducting a discriminant analysis in SPSS to be useful. As always, if you have any questions or concerns, feel free to contact me, and I'll be happy to assist you.